Online people, can you still see?
Yeah.
All right, let's do it. Okay, we're the same thing except we're doing it for the point 3, right? So the point is 3/11, right? So I'm going to grab a calculator because I'm not prepared for class. I would pick 3.1, and then comma, that would be 3.1 squared. 3.1 squared plus 2. And I would get 11.61. Agree? And then I'm going to do 3.01, because I'm approaching 3, correct? And that would give me that squared plus 2 gives me a whopping 11.0601. So far, so good. Miss Flynn, I'm going to ask you to guide me through this one. Okay. What about x? What if I wanted to find any point? What would be my point? It would be x, comma, x squared plus 2, wouldn't it? That would be the any point. Agreed? Now I want to pick a point close to x. What's a number close to x? You have to be a whole lot louder because if I can't hear you, they definitely can't.
X, like the actual like 3?
Well, x, any number. Right? What we do is we pick points close to it, correct? How do we pick points in the land of variables close? This is what we're going to do. We're going to do x plus a little bit more x, which we write in math land as delta x, meaning a little bit more x. And you've seen this before because we foreshadowed it, and you've been afraid of it. Here's where we're going to use it. X plus a little, the delta x means the 0.1 we're choosing, or the 0.01 we're choosing, the little bit more. You good so far? Now, what happens to my y then? I'd plug this in, wouldn't I? And I would get x plus delta x squared, right, because I'm plugging in for x, plus 2. All right, so let's go back to the land of numbers where we're more comfortable. What do I do over here to find my slope? Let's take the first 2 points that I found. And it would be, sorry, one more time?
3.1 minus 3.
On the bottom. Maybe, oh, my pen is now freaking out. Nope. It's smarter than me, so it thinks I didn't want to write on the board. 3.1 minus 3. On the top, I'd have 11.61 minus 11. Agreed? Then I would get 0.61. No, I get 0.61 over 0.1 or 6.1. Agreed? And that's how we do it when we've got a number. What about this side? Slope. How do we find slope? We took y2, which would be what? X plus delta x squared plus 2 minus
x squared.
Okay, you got to be a whole lot louder. Either my hearing is going or the mask is killing you. All right, what else you got? What's the x's become?
X plus delta x.
X plus delta x
Minus x.
minus x. Oh, that's a terrible minus. Okay? All right. And so I'm going to clean it up a little because it's scaring the heck out of me. But I'm going to clean up a little, and I get x squared plus foiling this, I would get 2x delta x's. Now I'm pausing there. Does everybody see the x delta x's, or should I foil this thing slowly? You don't see it? Okay, let's do it. All right. I'm going to foil this together. It's got a plus in the middle, correct? Right? So it's going to be x plus, I'm going to write it over here and erase it. X plus delta x times x plus delta x, agreed?
Yeah.
And then first is what?
There's x, so x squared.
X squared. Then I'd have an x times a delta x, right? Which is just x delta x, right? Then the inners?
Then another x delta x.
X delta x. And then the last?
Delta x squared.
I love it. And you can see you put those two together, agreed?
Yeah.
All right. So we're going to go over here. We're going to go x squared plus 2x delta x plus delta x squared plus 2, because I still have plus 2 sitting there, minus x squared minus 2, agreed? And then I got x plus delta x minus x. Miss Flynn, what does that become?
Sorry, say it again.
I got x plus delta x minus x. What does that become?
Just delta
Delta
x.
x. So far, so good? You're like, oh, this is crazy. Okay, just bear with me just a smidge longer. We're good. We're doing good. Okay, cancel out some terms, right?
Yes.
What can I cancel out, Flynn, when you're ready?
It's not
X
x squared.
squareds. Boom, we don't need those anymore. The 2s, I get rid of 2s. That's fun. But I still got something that is so ugly, it's hard to describe why this would ever be useful to me in a math class. Right? What's that? Ugh. Oh. I don't even know what I found there. What am I doing? But all we did is replace the numbers with variables, right? So now we have a generalized form of it. All right, let's finish it. Oh, are you ready? I'm going too fast. You know, I'm going past lots of people. Everybody good? All right, Flynn. Let's go back over here. What do I do now? Plug 3 in here. So, no, not doing this yet. I'm still over. Let's see if we can finish this problem here. Yeah, let's do that. And so I get 11.0601 minus 11.61 all over. No, I did the wrong point. That's not the right point. Minus 11, right? Over 3.01, sorry, minus 3. Put in my calculator, I get actually 0.0601 divided by 0.01, which is 6.01. All right, Miss Flynn. Are you ready to tell me what we're approaching, or should we pick another point?
6.
Looks like we're approaching 6. I'm going to agree with you. Looks like we're approaching 6. Oh, wait. Whoa. Yeah, looks like we're approaching 6. So I'm going to be with you, and I agree with you and say that's great. Now, we got stuck here because we had nowhere else to go with this problem. But I would suggest the following. We just did something here. What did you do? What do we call it when we pick numbers closer and closer to find a better value? You may have said it. Do you say it? No. Go loud.
I don't know.
You don't know. What do we call it when we pick points closer and closer until we can find the right value? What do we call it when we're trying to figure out what slope we're approaching but not reaching? What do we call that process? Finding the limit. And we're finding the limit as we pick smaller and smaller little delta x's, right? So let's find the limit. So now I'm going to shrink this out of my way. That didn't work. I'll try it again. Shrink this out of my way. Oh, my computer's just about had it. Come on. Try this. Nope, won't let me do it today. How about this? Nope. Wow, it's completely losing its mind. Marbles. Okay, so let's do this. I'm going to take the limit as delta x approaches small. What's small? What do I really want it to be? 0. So I'm going to take the limit as this thing gets closer and closer, as delta x gets closer and closer to 0. Now we just did a whole chapter on limits. The reason for that was because we wanted to be able to do this. We want to do this very thing right here, right now. How do I take the limit of this? I can copy this and move it over. Just let me have that, okay? Okay, good. Copy. Copy. Here we go. Paste. Paste. Nope. Yeah, give it to me. All right, here we go. Let's round it and move it out of here so I can take a look at it better. All right, do limit of that thing.
Well, first you try to plug in 0.
I plug in 0, and this is squared up here, and I get 2x times 0 plus 0 squared all over 0. That's 0 over 0. Frowny face, can't do it. Shock of shocks. Now what do I try to do? I try to factor out. What can I factor out at top and bottom? Delta x. Agreed? Oh, wait, the bottom goes away, right? Now I plug in a 0. Oh, I'm going too fast. Now I plug in a 0. What do I get?
0.
No, that's an x.
Oh.
That's an x right there. I'm going to get 2x. Which is what? How'd that help me? This is the slope. The generalized form of the slope, is it not? That's what we just did. What is the slope when x equals 0?
0, 2.
If I plug 2 times 0, I get 0. Slope is 0. We found that earlier, didn't we? What was it when it was 3?
6.
6. Slope at 3 is 6. What's the slope at 4?
8.
8. Just plug in a 4. You're done. This is the slope for everything. This is the slope for all things on this curve. We've found the slope. We've officially done what we couldn't do before, which is find the slope of a curve. Do you want to know what the slope is in a million? Tell me what the slope's in a million. At x equals a million, what would it be? What's the slope? 2 million. Thank you. Did you say that, Lon? I just didn't hear it. Sorry. Get out of mask. Okay. So this thing right here that we just took is called a derivative. It tells us the slope for any point along that curve. Now I'm going to pause this for a